Alright, we're going to start the second half of our quadratics unit today. And what we're going to look at is how to solve a quadratics equation. We know in standard form we had y equals ax squared plus bx plus c. What's different now with a quadratic equation is we don't have the y equal to, but instead it's equal to something else, and often it's going to be equal to 0. That's usually the easiest way to solve these questions. So we're going to look at 4 different methods of solving these. We're going to look at graphing, solving them algebraically, if it's in vertex form, factoring, and the quadratic formula. So today what we're going to do is just look at solving it by graphing, and then we'll look at the other methods later on. So to solve by graphing, we basically want to have the equation in any form. Usually it's standard form, but it can be in any form, and we just want to make it equal to 0. Because we're basically, in our calculator, we're going to graph this as y equals. So the question then is, where would y equal to 0? Well, that's going to be where our x will make it equal to 0, which are the x-intercepts. Okay, so basically to solve by graphing, we just solve for the x-intercepts. And we usually call these solutions the zeros of the equation, or the roots. So x-intercepts, zeros, roots, all mean the exact same thing. So on your calculator, if we get an equation that looks like this, 2x squared plus 2x minus 12, all you have to do on your calculator is graph y equals 2x squared plus 2x minus 12. You'll get your graph that looks similar to what I've got on the page here. Then to actually figure out those zeros, go to second calc, choose 0, that's why it's called 0. And remember, you just got to go left and right. So if you move your cursor somewhere over here, that'd be the left of the 0. Go somewhere down there, that'd be the right of the 0, hit enter, and it'll give you -3. Then do it again, go second calc again, go left of the other 0, which will be below, then go right, then hit enter again, and it'll give you the 2. So we know that -3 and 2 are the solutions. So then what you want to do is, sometimes it's a good idea, is just to make sure you got it right, is if we plug -3 back into the original, so if you put in -3 in for x, and solve that, see if it actually equals 0, it does, you get 0 equals 0. And if you put in 2, do the same thing, but put in a 2, you can verify that that one is also true. So if you plug all that side, you'd get 0 as well. So 0 equals 0 for both sides of the equation. Okay, so let's try another one. So in this case, if we graph y equals -x squared plus 8x minus 16, you get a graph that looks like this. And you can see from the graph, it looks like it only crosses in one intersection plane. So same thing again, go second calc 0, choose left and right, and it'll give us x equals 4 as our solution. So when we graph, just by looking at the graph, you can tell if there's 2. Like in this case, we had 2 x-intercepts. In this case, we only have the 1. And it's also possible that we would get 0. Okay, so here's another one with 2. So here's our equation. You can see the equation's not written in equal to form, in equal to 0 form. So that's usually all you have to do, is rearrange it so that it's equal to 0. So you could graph, the easiest way is just bring the x squared over. So you could graph 100 plus 15x minus x squared. That would work. Or if you wanted to bring everything over the other way, if you went x squared minus 15x minus 100 equal to 0. So either of those two equations will give you the same solutions. If you do it the first way, the graph looks like I've got on the screen. If we were to graph y equals x squared minus 15x minus 100, it's going to be the same graph but upside down, but it'll still cross in the same locations. And because we're only worried about the x-intercepts, it'll work either way. So in this case, go second calc 0, do your left and right, and we get -5 and +20. So here's one that doesn't work. So once again, you'd want to rearrange this. So we'd put it as 2x squared plus x. Bring the 2 over, so make it +2, so it's equal to 0. Graph that. And when you graph it, you get a graph that looks like this. And you can see there are no x-intercepts. Right? There's nothing that crosses the x-axis, so we just say no solution, or another way of saying it is there are no roots, no zeros, no roots. So that's it for graphing. So it's pretty easy. Basically, the good parts about graphing is we can put in any quadratic equation. It doesn't matter what form it's in, vertex, standard form, or anything else. And it's pretty easy to find those x-intercepts on your calculator. Just put in second calc 0 and away you go. And what's also nice about the graph is you can see visually if there's 0, 1, or 2 solutions. The downside of doing graphing is If you get decimal answers, your calculator is just going to give you a decimal approximation. Often we want exact solutions, so that's going to take a different method in order to get exact. And the other downside is it's kind of slow. By the time you type in the equation, do your second calc, it takes you a little bit of time to find those solutions. But if you have the time, it's definitely a pretty handy method to use. And that's all. We'll look at the other methods over the next couple lessons.